For this third part of our conversation regarding time value of money, though you have the PDF, right, of the presentation itself, I'm going to go directly to Excel. Okay, so I'm going to be using the Excel template to solve the rest of the problems just because it's much more efficient and it's a great tool that should be at your disposal and should be understood. Okay, so let's go ahead and just apply these concepts to solving these problems, right? So here's problem number 3. An investor wants to have $50,000 in 4 years. Wants to have, that means that this is a future value, correct? And in having $50,000 means that basically, they want to be able to receive or withdraw this amount. So as a future value, I'm going to type in $50,000. If he deposits $29,604 in the bank today, so $29,604 in the bank today, okay? With annual compounding, okay, what interest rate must the bank pay for the investor to reach his goal? Okay, so what is the rate that this investor needs to earn in order to go from $29,000 to $50,000 in a period of, here it is, 4 years? Okay, so I'm going to show you a function called the rate function. This is I, or interest rate, or rate. I mean, either way, remember. Okay, either way. It's a rate function in Excel, and I'm going to show you something. You will see that we're going to have a hiccup, a problem, and I'm going to explain why that problem occurs. Okay, but let me show you the function. It's called rate. So just type in =, and then rate, and you would immediately see that function right here. Double click, and just to understand what it's asking, press FX, right? And then it says, given the number of periods, that's easy, that's 4. The payment, there are no annuities here right now, so it's just an initial amount and then the final amount, so there's no payments, no periodic payments to be received or paid, right? So the present value is 29, that's what we start with. The future value is $50,000, and it's always left a blank because we assume end of period payments, okay? If you press OK, you will see that Excel can't solve this problem. Why is it unable to do that? Remember the sign policy, right? The sign says that if you are investing something in order to eventually generate an amount that you can later retrieve, then that investment, that deposit, has to be negative, and anything that you receive will be positive. So the $29,000 should have been placed as a negative number. And when you do that, then the answer is easier to calculate from Excel's perspective. So you need to earn 14% a year so that after 4 years, the $29,000 would become $50,000. Okay. The fourth problem is you want to purchase a home. You estimate that you will need a $20,000 payment. So you already know that the future value that you're looking for is $20,000. If you have $14,000 today, so today, right, the initial amount that you place is $14,000. So remember, this is 14. Now negative, right? We learned our lesson. And your bank is offering an 8% interest, so 8%. How long would you have to wait in order for the $14,000 to become $20,000? Notice that while the previous one, the unknown was the rate, now the unknown is the number of periods. Okay, so we're just going through the motions of different types of problems. This will be the function is number of periods, NPER. Okay, double click, as before, FX, and now it wants a rate. The rate is 8%. No payments. Present value would be the 14. Future value would be $20,000. Leave that alone and press OK. So you have to wait around 4.63 years. Okay, that's the answer. Let's go to another one. Samira would like to accumulate $100,000 to purchase a retirement home. She can save $3,000 each year, and invest it at 11% compounded annually. How long will it take Samira to reach her goal? Okay, so she wants to reach $100,000, right? So that's the future value. Okay, and notice that she doesn't have any money right now, but she believes that she can save $3,000 each year. So the payment that Excel wants, right? That is the annuity, right? She can deposit $3,000 every year. Because she's depositing the $3,000, this will have a negative sign, right? So here it is. Okay, and the fact that you're putting it as payment means that this is something that repeats itself. Okay, it repeats for every year. Now we know that the interest rate that which you can earn is 11%. So what is the unknown? The number of periods. In this case, we're going to use the same function as before, the NPER function, the number of periods function. Okay, and as before, right? We need rate. That's 11%. The payment that we left empty before, now we click on the $3,000 because now we know that there are repeated deposits. Okay, every year. The same amount with the same periodicity. No present value. In other words, she doesn't have anything already in the account, so that's the one that we're now going to leave empty. The future value that you want to reach is the $100,000, and press OK. And the number of periods is 14.76 years. Okay. Number 6, your son was just born and you want to put aside some money for his college expenses. On his first birthday, okay, so when n is equal to 1, right? When he's 1 year old, because right now he's just born, so the age is 0, right? Let's just say. And each year thereafter, so on every birthday, you plan to deposit $1,000 into an investment account. If you put $1,000 every year, then this is an annuity, right? So these are payments that you're going to make. Now this account earns 12.18% return, okay? And this is compounded every year. So the question is, how much will there be on his 18th birthday? How much will your son have in his account by the time he's 18 if you deposit $1,000 every year? Okay, so what is the payment amount? The payment amount is, again, negative 1,000, right? What is the interest rate that you're earning? Is 12.18%. Sorry. Okay, what are the number of periods that we're talking about? 18. Okay, from 0, n equals 0 to n equals 18, right? And what you don't know is the future value, right? So equal to future value, okay, the future value function. And remember, it wants the rate. What is the rate? Here it is. Click on that. The number of periods. Okay. Click on that. Payment, $1,000. There's no initial amount that you have in his account. And the type, they're always end of period cash flow. So you press OK. He will have $56,777 in his account. Okay.